Hello everyone, I'm Harshavardhan, a first-year computer science graduate student at the University of Chicago. Today, I'm excited to share the final project I had developed as part of the intermediate Python course, an interactive business intelligence tool. For those unfamiliar, a BI tool, short for Business Intelligence Tool, empowers organizations to extract trends and insights from their data, which in turn facilitates them to make informed decision making. Some of the examples of popular BI tools include Power BI, MicroStrategy, and Tableau. While my BI tool is not as fancy as those, one feature that stands out uh, in my tool is the interactiveness, a feature I'm eager to demonstrate in this presentation. Now let's dive into the tool. It comprises of three sections: dashboard, search, and about section. We'll mainly go through dashboard and search section today. As you can see, the default screen for the user is search section. Here, user inputs queries in the search box, and tool analyzes and transforms them into graphical representations. For instance, typing help to display me all the available data set that I have imported into this tool. Those are OList and GameStop. This showcases the modularity of the tool. We can import as many datasets as we need. Here we have two datasets. Those are Help Olist, Olist and GameStop. Olist is a Brazilian e-commerce company for which data has been downloaded from the Kaggle, and GameStop data. Here I mainly have the GameStop stock data. If we click on one of the helps of Olist, let's say, it will take us to the help Olist section. Here, it is giving me all the sample queries, measures, and dimensions that are available in the list. Measures are something that are aggregatable columns. Dimensions are something that we can group by. Those columns that we can group by. In order to save some time, I won't be typing all the queries manually, but rather I would just use the sample queries, which it is intended for. If I type like some simple query, let's say I want to show the payment value data that is grouped by payment type, can you search for it? And here it is. As you can see in this graphical representation, I can even change the display type. I can change it to line. I can change it to scatter. I can even change it to pie. The default is bar type. Now going back to help Olist again. Let's say I want to find the average review scores of each customer that are grouped by customer state. And I also want them to be between 3 and 4. Let's say I can just do that using this query. I want to show the average review score data that is between 3 and 4 and grouped by customer state. I can just search for it. This can take more time than usual because it involves joining multiple tables. And here is the output. As you can see, it has grouped the review score, average review score by the customer state, and it is between 3 and 4. Now let's go into one more type of query we can ask for. Let's say we want to get the top 15 prices which are grouped by customer state. We can just do just that. I can click on search. Pardon me. It showcases the top 15 prices that are grouped by customer state. Well, let's say I want to filter the data. Let's say on the basis of some dimension. I can do that as well. Here, the last query does exactly that. I'm aggregating the price and grouping it by customer state, but I want payment type to be credit card. This involves joining 3 tables, so it could take more time. And it does take more time. And we have it here. This showcases the Polish data. Say we want to see the GameStop data. Now only imported stock data of GameStop into the dataset, into the models. That is why we can only see sample queries for the stock data. Let's say for the GameStop, we want to see the volume of the stock bought and group it by corp date. but I want it to be between 1 and 1 million. I can do just that. I can just search for it, and it gives me that data. I can zoom in as well. I can, and each of these lines represents a date. And I can go to line. Maybe that gives me a good representation of the data. As you can see, here we ran multiple queries in this session. For example, we asked for show GameStop volume between 1 and 1 million and grouped by COP date, and all these other queries which we have ran. And for an user, you don't want to type this every day, right? If the data is dynamic, we don't want to type these every day, but rather we want to run them by one shot. This is where dashboards come in. I can save this or my session as a dashboard. That is where the save button comes in. I can just click on save the session, and it asks for some dashboard name. I'll create a new dashboard. I'll type it public dataset, public dashboard, and I'll get it as public presentation, and click on OK. Now this resets my session, but it will create a new dashboard, as you can see here in this public representation. And as you can see, there are two data sets which I've created before as well. That is OList data and GameStop stocks data. If I just click on public presentation dashboard, this should run all the queries which we had run in this search session, and give all the graphs in one shot. As we had run multiple queries, it would take some time because it has to run all those queries. And it is giving me exactly that. We type show payment value, payment type, show price where payment type is credit card. We ask for GameStop volume data. Everything is here. This is the power of dashboards. If the data is dynamic, then every time we run this query, the data would be different. And that concludes my demo part. Now let's dive into the coding part of my tool, which is presented here. For this tool, I have used three libraries in Python. First is Django for my web framework. Second is Networkx to find the shortest distance between tables when we had to join multiple tables. And three, I have used Plotly to generate the graph. Django uses MVT model, that stands for models, views, and templates model. First, we'll go to models file. In models file, this is where all our models are actually tables sit in. For example, I have like multiple tables for OList. I have geolocation, I have product, I have customer, I have order, and each of them have multiple columns. And for order ID is the primary key, and which I have set that. And if we go to, let's say, order item, it has all the foreign keys, which we can see from here. Order ID, and it points to order, which we have just seen. It points to this order primary key. And for whenever you want to import some new data set, you would want to create all the models that are required for them. For example, I want to import GameStop stock data, for which I have created a new model for that, such like that. Example. And going to the second part of the Django model, Django is the views model. Views. This is where it will, whenever we click on this search, this is where it comes in. It will come to this search view, and all the data, it will be present in this request part. When I type on help and click on search, it generates a search text, and it will give it a search view. And I have extracted that here. And if the search text is empty, I'm returning empty rendered HTML template. We'll go through template later. And if it contains help, it will give the metadata for each of these data sets. For example, if it's help, it will do that. It will give it all the data sets that are available. If it's help OList, it gives just that. It will written all the measures, dimensions, and sample queries that are presented in the metadata. Similarly, for the GameStop, we need to hardcode the metadata here. After, if it is not help, then it's a default, let's say, user query, right? It will get the plot type first, what type of plot we want. The default is bar, and if we type pi, it will come here again. And this is, we have got the search text now. Now we need to analyze the search text and generate the data. And it all happens in this generate plotly plot. Here you can see we are passing search text this, and first thing we want to do is extract information out of that search text. What is user grouping it by? What does user want to aggregate it by? Such like some information like that. And it all happens in this extract information. Here, you can see I have multiple regex patterns, and it will try to match my query with these regex patterns. As user wants more and more dynamic queries, we can add more and more regex patterns. And as you can see, there are like multiple patterns in the extract information I have passed in the query. I am trying to match the query with these NLP regex patterns, and it extracts that information. And one more feature is the alias. For example, in the models, if we are taking review score, I just don't want review space score should be the only name for it. Even if I want score, it meant review score. That is where aliases come in, and it is all stored in this aliases table, all the data. And going back to views and extract our generate plotly and then extract information again, it finds all the aliases. And if it is a top pattern, if it matches with the top, it expects some kind of information, some kind of top number, and what to aggregate by, what to group it by, and it extracts all those information and create a JSON, and it will also validate that JSON. For example, that it helps space some random data set. As you can see, it is giving me error, which it should. And it happens because of this validation. If it is between, I want some range. And if it is, as you can see, it does that. If it is show, I just want some simple columns like what to group it by, what to aggregate it on. And it does exactly that. And if it is filter, I want the filter value, and I want on what column to filter it by, and it does use exactly that. And we are validating the JSON, and we are returning all that JSON return as JSON return to our generate plotly method. Here we have got NLP result. Now we're extracting group by and aggregate columns here. And now if two columns are part of two different tables, now we want to find the shortest path between them, which exactly does that. Shortest path uses Networkx to find the shortest path between those tables. As you can see, I have already added edges or relationships beforehand. Now, after getting the result, it should generate the query. Now, it got all the data it need, what to group it by, what to aggregate it by, all that data. Now, here I'm just updating the code which Django requires. If the intent is show top, I'm filtering only the top number. If it is show between, I'm filtering according to that. If it is where condition, I'm filtering it just on those filter value. And if it is show, I'm just ordering the query set as it is. Now, if it is bar, I will generate the bar chart. If it is line, I'll generate the line chart. If it is pie, I will generate the pie chart and return the value as plot divs back to my view. And it renders it, and it renders the return value, that is plot divs. If we and it uses search template here. Search templates are something where all the static files of Django sits in, such as these HTML files. If you go to search template, here we have all the HTML code, the CSS, the script, the JavaScript, everything sits in here. Similar to dashboard, similar to about, and even in individual dashboard section, everything sits in here, all the HTML code. And before I conclude my presentation, I also want to show you how to let the data. We can do we can do that by using populate data. And if some new data is present, it will insert the data. If no data is present, it won't insert any data. And the code for that is presented in populate data in this management section. And that concludes my demo part. Thank you so much for sitting with me today. And this is Harsha signing off.